Hello friend, myself R. Mahajan presenting my next video on the topic P.I. particular integral. Methods to find particular integral. Case number 4, when function phi of x is in the form of x raised to m, then we can obtain P.I. by inverse operator technique. It is 1 upon f of d operated on x raised to m, and the technique is that from this f of d we have to take the lowest degree term as a common term, and after taking it common, the remaining term in the denominator is in the form of 1 plus phi of d or 1 minus phi of d, which we have to operate on x raised to m. Then transferring this to numerator, we get 1 upon lowest degree term as it is into 1 plus or minus phi of d, that bracket raised to minus 1 operated on x raised to m, and then expanding this bracket by binomial theorem, expanding that 1 plus phi of d or 1 minus phi of d raised to minus 1 by binomial theorem up to terms containing d raised to m. We have to consider terms up to d raised to m, means neglecting the higher power than d raised to m. We use these two results from binomial theorem. First one, 1 plus capital X raised to minus 1, its expansion is 1 minus x plus x square minus x cube plus so on, terms alternately positive negative. And second result, 1 minus capital X raised to minus 1 is equals to all terms with positive sign, 1 plus x square plus x cube and so on. Therefore, these two results are very, very important for the expansion of that function. Then let us see some simple problems how we can obtain the Pi of. Solve differential equation d square plus 5d plus 4 into y is equals to 2x plus 3. Given differential equation is of second order with y as a dependent variable, x as independent variable. The term on the right hand side is in the form of x raised to m. Therefore, this we consider as a single term, 2x plus 3. And then to find Pi, we use this technique. Given differential equation is second order differential equation, therefore auxiliary equation is d square plus 5d plus 4 equals to 0. Finding the factors of this term, factors of 4 are 1 and 4, d plus 4 and d plus 1 equals to 0. Product of these two is 4 and the sum of these two terms is 5. And then equating each term to 0, we get roots as minus 4 and minus 1. Roots are real and distinct. Roots are real and different. First case for CF, and therefore as per that CF is given by, it is C1 e raised to minus 4x plus C2 e raised to minus x, we call as equation 1. Then second part, Pi part, obtained by shortcut method using inverse operator technique. It is d square plus 5d plus 4, which we have to operate on 2x plus 3. Then applying the technique, from this denominator we have to take the lowest degree term as a common term. Here the degree of first term is 2, degree of second term is 1, and the degree of last term is 0. Therefore, we take this 4 as a common from all this. And then remaining term we write from right to left direction. Therefore, if you take 4 common from 4, remains 1 plus, if you take 4 common from 5d, remaining is 5 by 4 times d, and plus d square by 4. Which way to operate on 2x plus 3. Then it is, I have written in the form of 1 plus 5 of d. Here that 5 of d is 5 by 4 times d plus d square by 4. Then transferring this term to numerator, we get 1 by 4, 1 plus 5 by 4 times d plus d square by 4, and that raised to minus 1, and then 2x plus 3, operated on 2x plus 3. Expanding it by binomial theorem. It is in the form of 1 plus capital X raised to minus 1 up to terms containing d raised to m. Here the power of or the value of m is 1, therefore up to d only. And therefore, using that we get, it is equals to, Pi is equals to 1 by 4. It is 1 plus capital X raised to minus 1. Its expansion is 1. Then minus x. X is here 5 by 4 times d plus d square by 4. Then plus square of it, square is 5 by 4 times d plus d square by 4, square of it, and then minus, and so on. Operated on 2x plus 3. Then simplifying it means expanding each bracket, and we consider the terms up to d only, means neglecting the terms of d square and higher. Therefore that Pi is equals to 1 by 4 as it is, 1 minus any number raised to 1 or any bracket raised to 1, its expansion is the same term, and therefore its expansion is minus 5 by 4 times d minus d square by 4. That minus d square by 4 we neglect here, therefore considering only first term, that is term of d. Then the expansion of this a plus b whole square, its expansion is a square plus twice ab plus b square, means if you expand this bracket we get first term with d square term, which we have to neglect. Twice ab means 2 times d raised to 3, that also we have to neglect, and b square means d raised to 4. Therefore neglecting every term from the second bracket after expansion, therefore plus so on, and which we have to operate on 2x plus 3, and therefore it is 1 by 4 times operating or multiplying term by term. Therefore 1 into this term we get same term, that is 2x plus 3 minus 5 by 4 d of 2x plus 3, and so on. it is equals to 1 by 4 times 2x plus 3 minus 5 by 4 times d of means derivative of all these terms with respect to x. Therefore, derivative of 2x with respect to x is 2. Derivative of this constant term 3 is 0. And therefore, we get it is equals to 1 by 4 times 2x as it is plus 3 and minus 5 by 2. And therefore, it is 1 by 4 times 2x, cross multiplying it, 3 to the 6, 6 minus 5, we get 1 by 2. We call this equation 2, Pi. And therefore, complete solution is CF plus Pi, equation 1 plus equation 2. Complete solution for dependent variable y, CF is C1 e raised to minus 4x plus C2 e raised to minus x, and at Pi 1 by 4 times 2x plus 1 by 2 is the required solution. Of that given differential equation. Second example, solve differential equation d cube minus 7d minus 6 into y is equals to x square. The term on the right hand side is in the form of x to m, means it is case number 4 for Pi, and given differential equation is of order 3. Therefore, to find the CF, we write down the auxiliary equation. Auxiliary equation is d cube minus 7d minus 6 equals to 0. As it is cubic equation, we can determine its root by synthetic division technique. Writing the coefficient d cube 1, d square absent 0, d minus 7 and then minus 6. If sum of all is 0, then 1 is the root. Here the sum is not equals to 0, therefore 1 is not the root. Then we check sum of alternate term, means sum of even term is equals to sum of odd term. 1 minus 7 is minus 6 and 0 minus 6 is minus 6. These two sums are equal, and therefore minus 1 must be the root. Directly we can go for that minus 1. First term as it is, product of these two, sum of these two, again product of these two, sum of these two, product of these two, and therefore the last term is 0. Means that minus 1 is the root. And removing one factor from this cubic equation, the remaining factor is d square minus d minus 6 equals to 0. Finding the factors of this, factors are d minus 3 and d plus 2. Product must be minus 6, as we are getting that product as minus 6, and sum minus 3 plus 2 is minus 1. And equating each to 0, we get d is equals to 3 and minus 2, and therefore the roots are minus 2, minus 1 and 3. All roots are real and different. Roots are real and different. Means case 1 for CF, and then as per that case we write CF as C1 e raised to minus 2x, C2 e raised to minus x plus C3 e raised to 3x. We call this as equation 1. A first part of that solution, complementary function. Then in second part we find Pi part. Integral is obtained by that inverse operator technique. D cube minus 7d minus 6, which we have to operate on x square. Then as per the rule, we have to take the lowest degree term as a common term. Therefore, degree of the first one is 3, degree of second one is 1, and the degree of the last term is 0. And therefore, this is the lowest degree term. Taking that term as a common from all, therefore, if we take minus 6 common, here remains 1. If we take minus 6 common from this, here it remains 7 by 6 times d, and here it becomes minus d cube by 6, and then writing in the form of 1 plus phi of d or 1 minus phi of d. Here I have written in the form of 1 plus phi of d, which we have to operate on x square. Therefore, it is minus 1 by 6. Transferring this to numerator, we get 1 plus 7 by 6 times d, and we have to expand it by binomial theorem up to terms containing d square only. Therefore, that d cube term we can neglect here itself, or after expansion also we can neglect it. Here I am neglecting it before the expansion, and therefore considering only the term of d, and that raised to minus 1, and then expanding it by that binomial theorem. 1 plus capital X raised to minus 1, as terms are 1 minus x plus x square minus x cube, and so on. Terms alternately positive, negative. Means if we consider this term 7 by 6 times d as capital X, its expansion is, therefore we get Pi is equals to minus 1 by 6 times, first term is 1, then minus x. X means here 7 by 6 times d, then plus square of it. Therefore, square of it means it is 49 by 36 d square, then cube of it minus 7 by 6 times d and its cube, and so on, which we have to operate on x square. And after expansion, we consider terms up to d square only. Means neglecting d cube and higher order terms, and therefore we get it is minus 1 by 6 times of 1 as it is, minus 7 by 6 times d as it is, 49 by 36 times d square, and neglecting this, therefore plus so on, which we have to operate on x square. The reason behind to neglect that term is that the first derivative of x square is 2x, next derivative of it as 2, and the third derivative is 0. Therefore, third and higher order derivative becomes 0, and as it becomes 0, we can neglect it. And then it is minus 1 by 6 times operating it or multiplying it term by term. Therefore 1 into x square we get x square minus 7 by 6 times d of x square means derivative of x square. Derivative of x square is 2x plus 49 by 36. Second derivative of x square. Next derivative of 2x is 2. And therefore, if you simplify it, we get that P.I. as 1 by 6 minus x square minus, if you divide by 2, we get 7 by 3 times x plus 49 times dividing by 2 we get 18. This is the P.I. x square minus 7 by 3 times x plus 49 by 18 into minus 1 by 6. Therefore, complete solution is CF plus P.I. Complete solution is always for the dependent variable, and here the dependent variable is y. CF is C1 e raised to minus 2x, C2 e raised to minus x plus C3 e raised to 3x, and Pi is minus 1 by 6 times x square minus 7 by 3x plus 49 by 18. Therefore, this is the required solution. Next example, solve differential equation d cube plus 8 into y is equals to x raised to 4 plus 2x plus 4. Though here there are 3 terms, we consider this as a single expression, a single term with the highest power as 4 as a value of m, and therefore finding the solution, first CF part, auxiliary equation is d cube plus 8 equals to 0. As it is cubic equation, we can determine its roots by synthetic division technique. D cube coefficient 1, d square 0, d 0 and plus 8. Here the sum of all coefficient is not equal to 0, therefore 1 is not the root, or alternate sum is also not equal, therefore minus 1 is also not the root. Therefore by trial and error technique, we have to check whether plus 2 minus 2 are the roots or not, or plus 3 minus 3 like this. Therefore factors of 8, 2 is one of the factor, therefore I can check it for 2. 1 into 2, sum is 2. 2 into 2, we get 4, sum is 4. And 4 to the 8, last sum is not equals to 0. Therefore 1, that 2 is not the root. Okay. Then we check for minus 2. 1 as it is, product of this 2 is minus 2, sum is minus 2, product of this 2 is plus 4, sum is 4, 4 to the minus, 4 to the 8 with minus sign, minus 8, and the last sum is here 0, and therefore first root is minus 2. Removing one factor from it, the remaining factor is d square minus 2d plus 4 is equals to 0. Then we are not able to find the real factors of 4, so that the product is 4 and sum must be minus 2. Therefore we find roots by formula, minus b plus minus root of b square minus 4ac by 2a. and therefore it is b is here minus 2, minus of minus, it becomes plus 2, plus minus root of minus 2 square, we get 4, minus 4, a is 1, c is 4, and divided by 2 into a, and therefore we get this one as 2 plus minus 4 minus 16. 4 minus 16 is minus 12, divided by 2. Then it is 2 plus minus factors of that 12 are 4 3s are 12. Root of 4 is 2. Remaining is root 3, and root of minus 1 is I. Therefore, into I, and divide by 2. And therefore, we get that roots are 1 plus minus root 3I. Remaining two roots are imaginary roots. And therefore, taking a combination of that two types of roots, the first one is a real and different, and remaining two are imaginary. And therefore, combining that two cases, we get CF is equals to C1 e raised to minus 2x plus e raised to alpha x. Here alpha is 1, therefore e raised to x, C1 cos beta plus C2 sin beta x, and here we use the next constant, that is C2 cos of beta x root 3x plus C3 sin of root 3x, and we call this as equation 1. That is CF part of the complementary function part, containing 3 arbitrary constants C1, C2, C3, and the order of that differential equation is 3, and therefore whatever the solution we are obtaining, it is a general solution. Pi by inverse operator technique, 1 upon d cube plus 8, which we have to operate on x raised to 4 plus 2x plus 4, and then applying the technique of the rule for that x raised to m type of term. We have to take the lowest degree term as a common term from this denominator. Degree of first one is 3, degree of the last term is 0, and therefore we take 8 as common from all this. If we take 8 common from 8, we get 1, plus if we take 8 common from this, we get d cube by 8, and then we have to operate it on x raised to 4 plus 2x plus 4. Then transferring this to numerator, we get 1 by 8, 1 plus d cube by 8 that raised to minus 1 operated on x raised to 4 plus 2x plus 4. Then expanding it by binomial theorem. Up to terms containing d raised to 4, means neglecting d raised to 5 and higher order terms, and therefore we are using this 1 plus capital X raised to minus 1 as expansion is 1, then minus x plus x square minus x cube, and so on. Terms alternately positive, negative, and therefore that Pi becomes 1 by 8 as it is. If we consider this term as capital X, 1 plus capital X as to minus 1, its expansion is 1 minus x, x means here d cube by 8, then plus square of it, it is d cube by 8 and its square, then minus, and so on. If we square it, it becomes d raised to 6, and we have to consider terms up to d raised to 4, means we have to neglect this term and next terms. That's why I have not written here, I have written only die. X raised to 4 plus 2x plus 4, and therefore it is equals to 1 by 8, 1 minus d cube by 8 and plus, it becomes d raised to 6. D raised to 6, we have to neglect it, therefore I will write down dash, so on, and then operate it on x raised to 4 plus 2x plus 4, and therefore it becomes 1 by 8 multiplying and then operating. Therefore 1 into this we get x raised to 4 plus 2x plus 4 as it is, minus 1 by 8 d cube of that term is x raised to 4 plus 2x plus 4 and plus so on. Here we require to find out third order derivative. The first order derivative of x raised to 4 plus 2x plus 4 is first derivative is 4x cube, derivative of 2x is 2. Then second order derivative of this term is, means next derivative of this. Next derivative of this is 12x square, and derivative of that 2 is 0. And the third order derivative of the same term is derivative of this term, next derivative. It is 24x. And therefore, we have to substitute that value here. Therefore, Pi becomes 1 by 8 times x raised to 4 plus 2x plus 4 minus 1 by 8 times 24x. And therefore simplifying it, it is 1 by 8 x raised to 4 plus 2x minus 24 by 8. Therefore we get 3x plus 4, and simplifying it further, we get 1 by 8 times x raised to 4, 2x minus 3x, we get minus x plus 4 as the required Pi, equation 2. And then adding this with CF, we get the required solution, CF plus Pi. Therefore y is equal to, we get this term as a CF, equation 1, plus equation 2, that is 1 by 8 x raised to 4 minus x plus 4, and therefore this is the required solution. Therefore I try to explain how we can obtain the Pi when function is in the form of x raised to m. Important one is here, 2 steps. In first step we have to take the lowest degree term as a common term, whatever the remaining term, either in the form of 1 plus phi of d or 1 minus phi of d. That bracket we have transferred to numerator and then expanding it by binomial theorem up to terms containing d raised to m. In my next video, I will discuss the fifth case when function is in the form of e raised to ax into v, capital V, where that v is any function of x. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel if you are not subscribed yet. Therefore, quickly subscribe my channel to receive new videos or the new updates. Thank you very much.